So this session is to explain what Switchmap is all about, why it was created, and what some of the potential opportunities are for the application. Switchmap was created many years ago by a gentleman in the American Midwest, and he was a network engineer, and he decided that he was going to create a methodology of getting the basic topology of his network in some sort of a graphical format. And the way that he did that was to use SNMP. SNMP is a protocol that provides basic information about network equipment, and it has two general sets of data points. And the data points in SNMP are called object IDs, or OIDs. And when the SNMP standard first came out, they decided to create a set of mandatory OIDs, or OIDs, and they tend to be related to the performance of the device and things like the interface characteristics and statistics. So things that you can find in SNMP as standard OIDs would be the error rate, the amount of broadcast packets, the amount of unicast packets, and the amount of multicast packets, the amount of bytes that have been going through the interface, the name of the interface that has been assigned to it by the network engineer, and then also the name of the interface that is described by or defined by the manufacturer itself. And these data points are well established, and the OID structure is a series of digits like .1, .3, .4, .7, etc. And each one of these strings has different prefixes. So if you have a different path of those dots, that may mean one thing, and then if you have another path, that may mean another thing. And these dots and numbers are difficult to keep track of, and the way that you can keep track of them more meaningfully is to use a thing called a MIB, which is a management information base. It's just a translation file. And what will happen is that if you're doing an SNMP walk, you will find that the output of the SNMP walk will vary dependent upon whether you decide to use the MIBs in the translation or whether you don't. Now, one of the issues with using MIBs is that if you do the SNMP query for the particular data point using the string value of the MIB, it's a little slower. And if you use the numeric representation, it's faster. And I'm going to give you an example of this in a minute. The MIBs are things that you can download from the internet, and it really helps, because if you're doing the SNMP work and you're just working with the raw OIDs themselves, it can be a little difficult. However, when you're writing your code, you don't want to be using the equivalent MIB values because of this lookup process, which takes time. And the MIB files are not in any optimized fashion. They're just plain ordinary text files. So if you have a lot of these files installed on your system, the SNMP query is going to go load all those files up into memory and then parse through them individually to get to the actual dotted decimal format of the OID, and that takes time, which is why in the Switchmap application we don't do that. So I just wanted to let you be aware of that. Then there's let's see what else there is. Okay, do you have any questions related to what I've just said? Let's just start with that. All right, now what I'm going to do, I'm going to try and find some OIDs and some MIBs so that you can take a look and see what that looks like in reality. So just give me a moment here and figure out how to get that information. All right. So I'm going to share my screen, and I think that will be very instrumental in getting some of this understanding. All right. So this is what a MIB file looks like. This is the MIB for the well-known interface values. And as you can see, it's a plain ordinary text file. So here you see you have the if-MIB definitions, and it says that you can expect various types of objects coming out of it. One of them is being like a counter. A counter is just a constantly incrementing value. A gauge is a value that has a moment in time value. So a counter would be the number of packets going through a particular interface, and that it would just be counting. And when it reaches the limit of that integer value, the count will just reset back to 0 and then continue. Gauge values would be things that you don't really want to track on a historical level, and that would be things like the temperature of the device, for example. And as you can see from the MIB, we have all this textual information that you have to go through. And not just that, it also talks about the other MIBs that need to be loaded up before in order for you to translate the entire string of information in the object ID. And what do I mean by that? Well, let's just bring this up. So here you can see the numeric representation of this MIB. And as you can see, this MIB is located at .1, .3, .6, .1, .2, .1, .2, And this is why in Switchmap, we use the dotted decimal, which is this format that you see here, and not the MIB value. And what you'll see here is that this is where the if-MIB starts. And then after that, you'll see that there are these other numbers. And so if you have a MIB that is 1.3.1.2.1.2, but then is followed by a .2, that means it's giving you the information that is the description of the interface. If it's followed by a .3, it's the information interface type, whether it is Ethernet or some other type. Then it talks about the mean transferable unit. I think that's the packet size. The speed of the interface is something else that you can get. And so as you can see, there are some things that are integer values, some of them that are gauge values, things that are like hexadecimal, they'll be like octet strings. Some of these will have this, if it's a .7, you'll see this other information here. So this is really important information that you can use. So hang on, I'm just going to make sure, I'm going to pause the recording just a moment. Right, so I'm going to restart the recording and make it more visible to you. All right, so let's just take an example here, and all right. So the thing that we were looking at before was this one. Right, and so this is the if-MIB, and I'm going to just pull this particular value here, and so here I'm using the Switchmap user, which is in the documentation. My local host is running the SNMP server, and I'm trying to get information from the if-MIB. And as you can see, you just get this long string of numbers, and it's very difficult for you to identify what each of these means. Some of them you can, but some of them you really have no idea. And so what you can do is when you enable the use of the MIBs, then it works a little better. So let me just do something here. So if I want to do just the interfaces, okay, it's not working so well. Let me just give me a second here. Trying to figure out why. Oh. Let's see if this works now. There we go. All right, so as you can see here, we now have this, the same thing was done, and here you can see it's the ifmib. However, now you see more meaningful information, right? And as I was talking to you before, you can see the if description, the if type, and here you can see the if description, the if type, right? And why am I showing you both methodologies? And the reason why you can use both methodologies is, say for example, you want to get this information. So let's just say, we just output this to a file called one.txt, and then I want to show you that you can do the same thing without the translations. And see, you get the numbers now, and whereas before you were getting the actual representation. So let's just do this. Right. So what I want to show you is that one of the ways in which you can figure out the translations and make sure that you're getting the right thing, if you've got the MIBs enabled, is that you can just take a look at the files that were just created. So like you can do /temp one.txt, or let's just do the top one. Let's do head/temp/ one.txt, right? And then if I do 2.txt, what you can gain from this is that you know that when you do it using the number methodology, that, for example, this first entry here matches this entry, the first entry here, and that the 10th entry that's here matches the value here. So in your code, you don't have, you shouldn't be using these values. You should be using these values, but you should be able to run your SNMP server using both methodologies, or your client using both methodologies, so it's easier for you to figure out what's going on. And what the site that I showed you before is really a good site for trying to figure out what the various OIDs are. You can do a really easy search, and there are a few sites that have this information. There's a university site out of France which has better search capabilities than the SNMP site that you see here. But that's the essence of getting SNMP done. So I'm just going to stop sharing just for a moment, and then I'm going to get back to the meet in general. So where am I? Got too many. Okay. Here we go. All right. So this should help you with some of the understanding of how this SNMP stuff works in just terms of polling and getting information, how this stuff was created. When I first discovered Switchmap, I found it very interesting, but one of the issues that I had is that it's very difficult to install it because it was written in Perl. And I decided to take it upon myself to rewrite the whole thing in Python. And it worked, and I liked it. I liked using it because, and the reason why I wanted to write it in Python was because Python packages are handled in a much more intuitive way. It was a scripting language of the moment, and I thought that it would be a good learning experience. And I liked it so much that I just also open sourced it as well, just like Switchmap was. And then when we created the Palisades Foundation, Switchmap was the first project that we had. And we decided to go into different directions, but this year we decided to recreate Switchmap as an alternative, as a product. And over the years, there have been many network engineers that have used Switchmap, and they have liked it. They have submitted issues and made pull requests to get it to work, and it has been really good. And the version 1 version was excellent, and it was relatively flawless. And then I decided that one of the shortcomings of Switchmap was that it couldn't get any historical data. And I decided to write it or rewrite it to the current version where it uses a database instead of storing all its information in YAML files like the original Switchmap would do. And the reason why I wanted to get this data for a historical level was so that you could discover where devices were and how the network was changing over time. And there are different ways in which this could be done. One of the ways in which the network changes is that laptops and mobile phones and things like that, they move across the network between different devices that are interconnected. And you may want to know where a particular IP address was today and where it was yesterday for various types of reasons. It may be there may be a bad actor, or you may want to do something like determine whether a security guard is actually doing their rounds and want to make sure that the IP address of their assigned mobile device that is doing that they use as a tool to help them verify or validate that they're going around the property is actually being used correctly. So there are different things that can be used for the reasons why you want to get this sort of historical data from a pure IP address perspective. But then there's another rationale for this, and that is because most network devices run a protocol called LLDP or CDP. LLDP is a link level detection protocol, and CDP is a Cisco discovery protocol or something very similar. And what happens is that on any network device that supports this protocol, they are multicasting and broadcasting these packets. And devices on the remote end of the cable that are also enabled with this protocol will respond back. And the LLDP data is very informative. It'll tell you information such as the interface of the device on the other end of the cable, the name of the device on the other end of the cable. It may even give you information about the type of operating system that is being run. It'll tell you whether I'm a Cisco or a Juniper. And in some cases, like with power over Ethernet, LLDP and CDP are used to negotiate things like the amount of electricity that the switch port must give to the device so that it can operate properly. And with this information, if you can get this information across all devices, across the entire network, then you now know how the individual pieces of equipment are individually connected. And therefore, it allows you to potentially create a topology map of the entire network. And that is an advantage that you can create. And Switchmap at the moment doesn't do that, but it could. And the current Switchmap has some real disadvantages in terms of the Python packages that it's using. The package that is used for creating the web pages is deprecated. It just used basic table formats, and it doesn't use anything that's more modern and responsive, etc. And so there could be an opportunity to think of new alternative approaches to the web UI. The other thing that also is a concern with the Switchmap is that it's a monorepo, and the monorepo handles competing or different types of operation. And what are those operations? Well, the first operation is the ability to pull information from these various remote devices. So you have a daemon that's running, and you configure it for the various SNMP parameters that are allowed by the piece of network equipment, and it goes out and it pulls the information. And then there's another daemon that runs, which is the API or the server. And the pollers are configured to post their data to a RESTful endpoint to the API. And the API accepts that information. Then, and through another process called the ingester, it takes that data, puts it in the database, and then you have another daemon that's running, which is the web UI front end. And all of these things at the moment operate on the same device, and this and running on the same device, and this creates an issue. And the reason why it creates an issue is because if you have a network with thousands of devices over hundreds of networks in dozens of locations, it means that if you have a single instance of Switchmap, that poller that's on that server, which also has the API and the web interface, has to have access to all of those thousands and thousands of network devices from a single central location. And that means you have to open up firewall rules potentially across networks, across countries, across security zones, all of these things, which make it not very practical for large-scale network deployments. Better approach would be to segregate or have different repositories for each of these individual use cases. One repository specifically for polling, so it could be written in a language that could be suitable for polling. Python at the moment is what we're using. It may or may not be the suitable language. And then that would then be able to send data back to a purpose-built API repository and its services, and it would handle that information in an optimized way. And so therefore you'd have people with expertise in this particular repository, another one in another repository, and then you'd have another one for the web UI and the web front end, and that would be a different methodology, potentially different languages or whatever. Now, if you did that, say for example, you had this network in which you had multiple countries, multiple security zones, etc., what you could do is set up a pair of pollers in each of these security zones. And then within those security zones, you could have a locally central API server. And so let's just say the office building zone in the country of France is being polled by these pollers, and then they then post their data to the office building API server. Now what that means is that, say for example, you have 300 office buildings. You don't have to have 300 office buildings going back to the central office. It just goes to the French API server. And then from there, you just need to open up a rule in your firewalls, etc., from that single French API server back to the global API server. And that allows it to be much more granular in terms of security that is required, and it just becomes a much better experience for the user. And so therefore, that allows you to scale. Now, all networks are going to be unstable. They're going to lose data for various reasons. And one of the things that we want to be able to do with Switchmap is to allow the devices to store data until it's safe for the data to be transmitted. If a poller cannot contact the API server or its respective API server, it should be storing the data locally, and then when the API server pops up again and it's available, then all the backlog data should then go to the API server. Now, you may have, like I mentioned before, you're going to have layers of API servers, one caching to the next one, going back to the central location. And when that happens, and the interaction between the various API servers needs to have the same methodology as well. It needs to have a store and forward approach to getting the data back. And this will just help with the ultimate scalability of the application. If we have a dedicated polar system, we could potentially create a situation where you have different polars for different purposes. And you could have one polar for polling the interface statistics, etc., and the name of the devices and all the IP addresses and that sort of stuff at a relatively slow rate, because that sort of information doesn't need to be, that's not going to be changing rapidly every 5 minutes. It could, but you could, it's not as meaningful in many cases. If you're paranoid about security and you just want to make sure that you have this sort of access, you may want to poll in a 5-minute incremental time, but it may just be suitable to just do this once a day, for example, until you think there's something suspicious going on. The other thing that you could do is create another polar that pulls more meaningful information that changes on a more rapid basis. So, for example, the interface statistics, the amount of packets that are going through, the amount of bandwidth that's going through, that sort of information. You could create a second polar specifically for that information, and then having representations on interfaces, etc. Because you're already getting this data using SNMP, why not just go the extra mile? Now, the way the polars work is that they don't know what device is being polled, and they have to infer that from the device that is polling. And the way that it's done is that there's a thing called a sysobject ID in SNMP. So let me just see if I can. Okay, here's a sysobject ID. Let me see if I can share my screen again. All right. Okay, where are you guys? I'll share the screen again. And so here's a sysobject ID, and I'm going to pull this for you so that you can see what it looks like. All right, so I'm going to make this a little bigger, but I don't think that was a good size the last time. Okay, so this is the long number for this particular device, but I'm just going to make it do the translation so you can see what it's all about. All right, so as you can see, this long string here is the equivalent of SNMP MIB sysobject ID 0, and this long string here is SNMP MIB whatever. This just so happens to be the string of a Linux Ubuntu system. And what you can do, what Switchmap attempts to do is it uses this value to determine what the manufacturer is of the device. And typically with a sysobject ID, this value, this little piece right here is the piece that determines what the manufacturer is, and then all the numbers that come after that tells you the model number of the device. And what we are doing with Switchmap is that we're going through and trying to determine whether it's a Cisco device or a Juniper device, and if it's one or the other, it'll try to get as much information as possible out of it. And this is useful because Cisco and Juniper have different ways of representing certain key pieces of information on their network devices. For example, the VLAN, or the virtual local area network methodologies, are slightly different. And there's some other ones related to the numbering of interfaces that are slightly different. In in the ifmib, there's an interface number or index number, and you can see that here. And that number typically is used in multiple locations. So for example, remember, like just say for example, this is the interface descriptor. And you know what, let me do this. I think it's if, right. Okay, so here's the interface descriptions. Okay. And you'll see that this is interface description, and then you'll see that it ends in a .1. Well, .1 in this case is the interface index value, which is what we saw right here, right? This interface index number. And therefore, you can say that this is the name of the interface number with interface number 2. This is the one with number 5. As you can see, I'm doing some Docker here, and I'm getting all of this interface information, and this information is then being transmitted back. The way Switchmap works is that, remember, one of these OIDs also can tell you whether it's the type of interface, whether it's an Ethernet interface, a non-Ethernet interface, a virtual interface, etc. And the way Switchmap works is that if it's not a Ethernet interface, it's not getting reported. So all this Docker stuff is not going to be reported in Switchmap. And because we're really just focusing on the network itself. So these are the ones that you tend to see. And when you're doing Switchmap on your local system, you'll probably only see one or two interfaces. One of them would be the loopback interface, maybe a Wi-Fi interface. And if your laptop has a physical Ethernet interface, that you'll find that there as well. This sort of information is important for Switchmap because it helps with the determining how things operate. So I'm going to stop presenting again. And this can be useful as I've mentioned before. And what happens is that because different manufacturers handle their certain key aspects of their machinery in different ways, we need to find a way in which we represent that universally in Switchmap. And so the MIB or the OID that is used by Juniper to define its VLAN structure is different from that of Cisco. And when the design was created, I didn't want to have a Cisco specific VLAN ID in the database and a Juniper specific value in the interface. What happens is that when the data is being dumped into the database, it uses the information from the YAML files that are submitted to determine whether it's a Cisco device or a Juniper device, and then it parses out the VLANs, and then in the database there's a specific VLAN column, and that is what is used. I think the columns that are custom have I think it's like a JM underscore as the customization in the name of in the column name, and therefore you can, rather than trying to write the web front end to determine whether it is a Juniper VLAN or whatever, because you have separate columns for Juniper and Cisco, you can get the VLAN information straight out of the GraphQL interface to get what you need in a very easy way. And so the pollers go through all the various MIBs and OIDs to determine what is required. And it goes through them in a specific order, and there is some overpolling. There's some stuff that is polled that is just, it's not necessary. When I was looking at the Switchmap library, I just polled everything that this guy was polling, and sometimes we don't really use those OID values at all. So there could be ways in which you could streamline and make things a little faster. There's some opportunities for async I/O. I don't know whether there's async I/O for Python and SNMP, so we just need to double check and see what happens. One of the issues that we also have with Switchmap is that it uses this package called EasySNMP, which is a pure Python SNMP package. And it is relatively slow, and especially if you have enabled the translation of MIBs that I showed you before, there's a way in which you can disable it, which is explained in the documentation. It makes it even slower. It can spike your CPU. And the way Switchmap works is that it uses multiprocessing, and it spins up separate processes for each individual device to get the information, and it just waits. So there could be some opportunity for async I/O. If there's an async I/O SNMP specific thing, that would be really, really useful. Why SNMP? There are more modern protocols, and there's a legitimate reason for asking the question, and there's also a legitimate reason for holding on to it. The networks are not as dynamic as your cell phone. When you want to have a new when you want to have a new phone, you change it out once every couple of years. But in many cases, network equipment is very expensive, and if the network equipment that is put on your network is obsolete and it's working, many people will just keep it on the network because the replacement cost is so high, and that the new equipment isn't offering any new features that the old equipment doesn't have. And therefore, what will happen is that you have, on a typical network, you have combinations of very old equipment and very new equipment. All the old equipment does SNMP, all the new equipment does SNMP and other stuff. So if you want to be able to get a good view of what your network can do, SNMP is one of those things. Now, just like with a server, where you have to, for example, enable SSH and that you use a password or a certificate to get into the device, SNMP is the same. SNMP is not generally open to the public, and therefore you're going to need to know the authentication parameters for access to the device. And if you have access to networking equipment, and if you're a student, go to your professor or somebody, ask them if there's any way in which you could get access to SNMP for reading data, and then you can probably get it. But the easiest way is just to set it up on your own local machine, like I just showed you, to at least just get some sort of an idea of what could be done. One of the ways in which you could simulate multiple devices and just multiple devices and new types of devices on the network as a part of your testing is to take a look at there's a directory in the test environment. So let me just see if I can go there, cd/ code. Okay, so if I do, no, I think it's not here. I think it's in test. Right. So if you go to this directory, test data _, you'll see these files, and these files are used in loading using data for loading into the database for some of the unit tests. One of the things that you could do is to copy this data into the ingest directory, and the ingester will automatically determine it. So if you take a look in Switchmap, there's an LS-var directory, and I think it's a cache. There might be an ingest, right? So if you, or maybe it might be just in cache. I think if you put these files into the cache directory, then the poller, the ingester will will find it, and then start processing it and putting it in the database. And you can copy these files repeatedly into this directory. The ingester will find it, put it into the database with a new timestamp, and therefore you now can get easy access to some sort of historical data. Now, I just want to talk about how let me stop sharing again. Oh, I wasn't presenting. So I'm sorry about this. Let me go over this one more time. You should have let me know that such stuff wasn't working right. Right. So here, let me clear here just to make it a little easier. So I'm in my Switchmap directory, and if I look in the test data directory, you will see these JSON files. And these JSON files are used by the unit test to validate data. And this is anonymized data, etc. So you can take a look at this stuff. And these files are identical to the files that are created when people or when the various pollers post to the API server. And therefore, when that data is posted, it gets put into the cache directory. So that's what the purpose of this var cache directory is. All right. Here is the value that I thought would be important for you. This value, purge after ingest. If you put the files in that directory and you set this value to false, the poller or the ingester is going to ingest the files and not delete them afterwards. And then in the next round of, like, after whatever the interval, the ingest interval, in this case the ingest interval is 1 day. If you set that to like 1 second, 1 minute, or 1 hour, or 5 minutes, or whatever it may be, if you set this, then when that time expires, it's going to see the JSON files that are there. Why? Because they weren't deleted the previous time, and it's going to say, oh, these are brand new files, and then it'll ingest them, and then in the next few minutes it'll come around and re-ingest them and continue doing that over and over again. So it's a way in which you can do some of this testing in an artificial way, and it'll be very helpful for you guys.
Yeah, so of those 3 files, only one is being polled. I don't know if it's the YAML or the JSON.
I think the files are posted as JSON. I think they are. Let me just double check. Yeah, so as you can see, one of these files is a YAML file. So you can convert that, you can copy that over, or you could also convert these files, these other JSON files, into YAML and just dump them over there in that same directory and go through the same ingesting process. And so that's something, and you can absorb that data repeatedly into into Switchmap and use that as part of your testing. And I think in Switchmap there's a way in which you can tell it not to delete those files after the ingesting. So then that is specifically for the purposes of doing it repeatedly so that you can get historical data. Even though the data is repeated, at least you can get something out of it. You could use those files and potentially modify them so that you can have the same sort of LDP systems on either end of a particular interface, and then you can start faking a network of devices with that information. And this is something I didn't mention on the previous call, but it's something that would be useful for anybody to consider. Okay, so just want to go over that one more time. If you were looking for files, for data, for testing, you can use this directory for that data. You can copy those files into the var cache directory and utilize the ingester for this. Now, there's some other stuff that I want to bring up with this whole methodology, and the concern may be, why is it that we have an ingester? Why is it that we just don't post directly to the API and the API just updates the systems or the database all at once? And the issue is that we're using a relational database. There's a real need for it because we need to have some certain types of structures. But many pieces of network devices, or many network devices, will have duplicated data. And you'll say to yourself, why would there be duplicated data on a network? And here's a good example of it. You may have two network devices, and they share a VIP. And that VIP just happens to be your default gateway. You're sending out information out to the internet, and so your first hop is going to be the default gateway, and that will go out onto the internet, and you'll get your results. The results will come back, but there's no guarantee that those results are going to come back along the same path, because the internet is dynamic. And so the data that is going out will always go out through your default gateway going out. But if there are multiple routers on your network, the return traffic may not. It may come through the second device. And all of a sudden, these two devices know your IP address and your MAC address, because they won't be able to communicate with you without that information. So two brother and sister devices, network devices on the same network, have the same mapping of IP address and MAC address. And therefore, when the poller pulls that information from the network devices, it gets this duplication. It posts that information to the API, and if the API is trying to keep track of the API to MAC address mapping for that network, and it processes the first device and then it goes and processes the second device, then you have an issue with potential collisions. Now, one way in which you could get around this problem is for every single MAC address, IP address combination, you do a lookup. Is this value already there or not? And then if it is, you do an insertion, etc. But what that means is that you all of a sudden have a huge amount of disk I/O for something that is relatively trivial in terms of importance. And therefore, what the ingester does is that it periodically gathers all the files in the cache directory, takes a look at their zone values, and it processes one zone at a time, and it tries to do the deduplication of known potential duplicate information. And then after it does the deduplication, it goes through and does the non-dedupe stuff, or the known unique things, and puts it into the database. Now, there may be ways in which to get around this issue, in which potentially the JSON files that are being posted, they could be set up or parsed in a different way so that they're deduped automatically without you having to do this Python magic to get that done. And so these are some opportunities for optimizations to make this thing faster. And this is part of the reason why we wanted to have the whole package worked out differently or better. There may be other opportunities for some newer protocols with the various pieces of network equipment, but at this time, we just want to get the SNMP functionality working, and then we can start thinking about other alternative approaches for additional data. And we may one potential for, like, in future would be to try and figure out how we can have diverse sources of information, store that information in a non-SNMP specific way in the database, but that is beyond the scope of what we want to do now. We want to have a product that uses SNMP, that makes network engineers happy, that is easy to configure, because as you've realized, it's not that easy and intuitive to configure, and we can get to where we need to be based on that. The switch map, because it has these various because it has these multiple different agents and things that are running, the configuration file now also becomes a little complicated, because you now have a server section, you have a Polar section, you have a web section, and all this other stuff. If we had it set up as separate individual repositories, each with its own different configuration methodology, then it would be less confusing. You would just say, hey, this is my Polar configuration, this is my API configuration, what's wrong, rather than showing this is my other stuff. And I think that would make it a lot easier for people to operate. It's not just the intuitiveness of the UI, but it's also intuitiveness of the configuration. It's also the intuitiveness of the setup process. All of these things are things that we want to make sure are captured in the design and the projects that you guys may have. So I've been speaking non-stop for an hour, and I think it's about time that I stop. But is this information valuable? I think I covered a lot more than I did the last time. I think the second time around is always better. Unfortunately, I've managed to record this. It'll be a much better experience for others. So do you guys have any questions? Is this clear? Okay. Okay,
Yes,
good.
sir.
Nishant, is this... I know that you've been sending information to the mentors. Is this clear for you?
Yes, it is clear. Like I have a I may sound
Right.
dumb, but I am trying to figure out how can we use like like how can we make the things asynchronous. So can you please tell me how do we get the data of devices that on which we do the polling part? Is it uh, do we get it from MIB or MIB that the folder that is present?
Oh, yes. Okay. So let me... The MIB or the MIB is just a lookup file. It is
Okay.
it is a representation of a part of that SNMP tree that I was trying to show you before. Let me see if I can find. Let me just see if I can go back and find some of this information. Hang on a second.
No, no, that is clear.
Okay.
Like, so I'm trying is that can we use another library along with Easy SNMP? Like currently we use Easy SNMP. So can we use Easy SNMP plus one more library that is async.io and in a threaded way so that both can work together and that way things are going to work faster.
Oh,
Will that be
yeah. Yes. Anything that we could potentially use. D- have you found ways in which you could use async IO with easy SNMP to combined?
right? I have
Okay.
and I was right.
Yeah,
So I
no,
was
go ahead. There's a delay. Please go ahead. I'll stop talking.
okay. Okay. So I was doing research and all. So I found a GitHub repository. So in that there was just a very basic part in which they use async IO along with SNMP. I don't know why they did that, but they used threading. And after that it was working fine. So I was thinking that if we can implement the same thing, like in some of the devices or more number of devices, we can use async IO. So it is going to pool the things asynchronously, and after that the data will be fetched in much
Right.
lesser time. And the rest of the devices they can use easy SNMP for fetching the data, and after that it can be given to the
Okay,
core.
hold on a second. So what devices are going to be using the async IO? The polars.
Like that is what I wanted to ask. Like, how are we getting the data of the devices that are going to get pulled? After that, only I can think about that thing.
Okay. How are we getting the data that's going to be pulled? The
Like, there are number of devices that will
yes.
be pulled. If we are clear that these are the devices that will be pulled, then after that we can divide. What I'm thinking of doing is that there are few devices that take less time to get pulled, and there are devices that take more time
Yes.
to get pulled. So the lesser ones can be like async IO can do the lesser ones, so it becomes faster. The ones that are taking uh, more than 1 minute or more than the specified time, they can use SNMP, and slowly their data will come towards the dashboard.
Uh,
But
I see what you're saying. So you are thinking about having the dashboard itself do the direct polling of, oh,
no, 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 no. I'm not saying that. It just came out
oh,
of
I
my
see.
mouth. So
So
like,
this would be for, so
right, the data will be going to
yeah, so, uh,
just wait for a while.
so everything would be pulled by the pollers.
Like everything will be polled by the poller. Async IO along with easy SNMP will be working. The the devices that take much time, they will be polled by easy
Right.
SNMP. The ones that take less time will be polled by async IO. The data will be going to the core after that. Then after that, the normal procedure that works
Okay,
after
why
the
would you
core.
want to do two different methodologies? Why wouldn't you just use one for everything?
The reason is, first of all, uh, like yesterday when I asked this question, you said that we cannot completely come out of SNMP right now, so we need to have a way in between. So that is why I'm using things along. I'm using two libraries at the same time. This is the only reason. And talking about, like, there is one more benefit why using two is better, because the devices that take a lot time, sometimes 2 minutes or 3 minutes. I think it will be better if we use SNMP directly for them, because I think it has been working
Okay.
fine for us. For
Yeah,
like that is the
but if
only
you're
reason.
using async IO, you'd be having to still use async IO over SNMP protocol, wouldn't you?
Uh, so like for that, I believe that for running two processes uh, together, that is why I'm using in them in a threaded way. Both are working together.
Okay, so you're using async IO, and then that feeds the data to SNMP, easy SNMP. Is that what you're saying?
Uh, No, no, I'm not saying that. Uh, I am saying like there are number of devices that we need to poll. Okay,
Right.
right. So some of the devices will be polled by async IO. Some of the devices will be polled by SNMP.
Okay, hold on,
Right,
hold on. Before you continue, it's going to be using
right.
async IO. Async IO getting data using what protocol? Is that HTTP?
So
SNMP?
I believe it is SNMP only. It is SNMP only.
Okay. I would talk.
Uh, I
This is something that
I just wanted
this is
to ask.
this is something that I'm not very familiar with, and you're
Okay,
going to have to figure this out on your own. But ideally,
okay, okay.
um,
I just wanted to ask whether we can do it in this way,
yeah,
because
talk
uh,
to Dominic, who's the mentor for the project.
okay,
He will
okay,
he
understood.
w- he was the one who did the some of the definition of what could be done with SwitchMap based on what he was of his experiences with it, because he wants to use it in his job as well. And therefore,
Okay,
he was the one who said we should be thinking about async IO, and therefore you should be talking to him about the methodologies to get that done.
okay, okay, understood, understood. I will be. I think I will be mailing him today.
Yes,
I will, along with the whole strategy that I'm preparing for it.
yes, okay. Yeah,
Okay.
as much as possible, work with the mentors. Like I mentioned in the call yesterday, I am
Right, right.
not
Okay,
going to be the mentoring the project. I'm going to leave that up to the mentors and also the selection of the people. And that's going to be the realm of the mentor. Usually, what my role in terms of selection for GSoC is, if a mentor tells me that they're going to select a particular person, I'll just tell them whether I think they will be successful. And if I think they'll be successful, that's it. I don't tell them that this person is better than that person. It's very extremely rare if I ever do that. It really is yes or no as to whether that's a good choice based on interactions over the previous few months. So all your interactions, as much as possible, should be with the mentors. Okay? All right.
Okay, understood.
Any other questions? Arpit, do you have any questions?
No, sir. I was just exploring a little bit into Switchmap-NG. I am mainly a full stack developer. I was interested in this field, so I decided to join today's session.
I could barely hear you, but I'm assuming that you don't have a question. Is that correct? Doesn't sound that way. All right. And Abby, do you have any questions?
No question, but like you were asking if we were able to poll like an SNMP enabled device, right? So I was able to poll my printer,
Okay.
and like it's being displayed the
Oh,
dashboard.
look at that. Fabulous. So now you'll be able to get information of your printer, and you'll also be getting information from your own local laptop, right?
And no, like that mode data you just mentioned before.
Oh, I see.
Yeah. So I can see.
The LLDP information of your printer. You can see that.
I don't know what is like. It's not fully displaying. Like the example file from test that I can see, and like some information about my printer too.
All right.
Yeah.
Well, it's just a question of you then just taking a look at the database and getting an understanding of what it can do. But if you use that methodology that I was talking about with the files and then just continuously importing them, that will also give you a way of creating a virtual network rather than you having to actually use your existing network as well. So there are different methodologies that you can use. Okay. All right. I don't have anything more. I think we've exhausted everything. Thanks a lot for taking the time to chat with me. I'm going to put this on YouTube so that people can get an opportunity to see this firsthand. Thanks a lot, and good luck with your GSoC activities, and all the best. Okay. Goodbye.